Alright, today I'm going to talk to you about physical properties. Okay? Physical properties. Alright, you had homework last week that was supposed to get you started on physical properties. So let's go over what a physical property is. Physical properties are the characteristics used to describe a substance. Okay, so it describes a substance. That's what it is. Okay? Describes it. It doesn't change it into anything new. It just describes it. So what are some ways to describe a substance? Let's think about it. You think, well, I am writing. Okay? Well, if we have sulfur, which I do have some sulfur, how would you describe sulfur? Okay, sulfur is yellow. Okay, so color. Sulfur has some powder that you can see at the bottom, so sulfur is brittle. It's easily broken. Okay, what else could we do? If it's got powder, what other word could we say? Powdery. Okay, so that describes sulfur. Okay, then we have some aluminum. Okay, so aluminum. Oops, I guess I fell. So sulfur, we have aluminum. Okay, so aluminum is shiny. Okay, that is also luster. Remember, luster is how it reflects light. That would be luster. And, we can say, to open this up, one thing about aluminum is, aluminum is malleable. It's shiny, it's thin, it's light, it's malleable. Okay, so another word would be malleable. Those are some good words. You need to know what malleable. Malleable is bendable. All those are physical properties. I haven't changed it anything new. It's just describing what it actually looks like. Okay, so another way to use a physical property to describe something would be the mass of it, which would be using, you're going to be using, being tested using the, on paper. Okay, so the first thing you're going to do is for triple beam balance is you're going to make sure that you circle your numbers. And then write your numbers out. 90 plus 100. And this here, you need to remember the individual numbers on this one is a whole number. If it's in between, you're going to have a decimal. So that is why this is 190.4 and not 194, because it's not on the 4 right here. It's way over here. These little bitty ones, 1, 2, 3, 4, 5, 6, 7, there's 10 in between. Those are decimals. So you're always going to have a 0.1, or you might have a 0.2, or you might have a 0.3, or so on. So make sure you know that if it's in between the whole numbers, you're going to have a decimal. So make sure you circle your numbers and write your numbers out. And pay attention to this bar here. This is where a lot of people mess up, is they count in between as a whole number. It's not. It's not a whole number. You can think of these as dollars, and in between, that is cents. Okay? Another physical property is volume. We're going to be using graduate cylinders and finding displacement of water too as well. Okay, you're going to be reading the bottom of the curve. But first of all, look to see what it's counting by. So start counting down here. Don't just assume that it's counting by ones. Sometimes they'll trick you down here and have it by 2s or by 5s. So 1, 2, 3, 4, 5. Okay, we know that's counting by 1s down here. So we're going to go to the blown up view. Underline with your marker. Underline the bottom of the curve. You're going to read the bottom of the curve, not the top, the bottom. So this will be 41, 42, 43. 41, 42, 43, because it's the bottom of the curve, not the top. So don't say 44, because that is at the top. It's not. It's going to be right here where this curve comes down to this line. It gets to be a little tricky. We can look at this one here. Okay, so the blown up view. Look to see what it's counting by. This one's a little bit harder, but it's counting by ones, and there's a 5, 10, 15, 20, and here's the blown up part of it. So it's the bottom of the curve. So you're going to take your highlighter and highlight it. Okay, so it's going to be 31, 32, and it's going to be a little m and a capital L to write your milliliters. Okay? All right. Another property is what's called conductivity. Okay, I'm just going to put this right on top of it. Conductivity is, does it allow electricity to flow through it? I've got a piece of wood here. I mean, do we have wood wires? No, we have metal wires. We don't have any wood wires. We use wood to burn with, but we don't use wood to make electricity flow through so we light our homes from. So if it's going to light the bulb, it's going to be conductive. So that would be a physical property. Another physical property would be temperature. Okay? Another one's going to be temperature. How hot or how cold something is. Thermometer. How hot is it? How cold is it? That's a physical property. That's pretty easy. Let's see what else. If it is the state of matter. I'm going to start taking some of this off so I can write some more. Okay? States of matter is physical properties. Is it a solid? Is it a liquid? Is it a gas? That's a physical property. Is it soluble? Or let me spell it. Solubility. This means, does it dissolve in water? Does it dissolve in water? Well, when you put sugar in tea, it dissolves, so that means it's soluble. When you put salt in boiling water with your pasta, it dissolves, so that is soluble. So that's a physical property. Insoluble would be the opposite of it. So, soluble, does it dissolve? Insoluble, does it not dissolve? Okay, so we have some more things that goes with physical properties that we can write up here. Brittle. Hard. Shiny. I mean, I could go on and on and on and on. Any type of description of an object is going to be a physical property. And that's why I had you do the homework last week on this. Magnetism. Yep, I went through all of it. States of matter. Okay, I've gone through everything on your homework from last week and recapped you with it. If you're still having trouble, you know to come and talk to me. Okay? All right. See you later.